Hello, this is Mr. Ensler, and I'm going to go over the Chapter 12 formative quiz. I said this was kind of like a practice test, and I know we're going over this in class, but just in case you really want to take a closer look at these problems and go through them one by one, that's what I want to do with you here. Number 1 says, which figure is not a polyhedron? Well, let's review what a polyhedron is. A polyhedron is a three-dimensional figure. So it's a 3D figure, and it is made up of only flat faces. So each face has to be a plane face. And you can see choices A and C and D, although they have slants to them, they are made up of only flat faces, whereas choice B has some curves to it. So that's another way to remember that if it's a polyhedron, it shouldn't have any curves. So which one is not a polyhedron? That would be choice B. Alright, number 2, a polyhedron in which the base is a polygon and the lateral faces are rectangles is a blank. And luckily you have a nice picture to go along with that on the test. Maybe there will be that, maybe not. Should be able to identify it just by the description. So the base is some kind of polygon. It could be a triangle, a rectangle, a pentagon, a hexagon, whatever. And the lateral faces are rectangles. And so that is known as a prism. If the lateral faces are rectangles, it means they're going to rise straight up, and the base polygon will be the exact same shape as the top base polygon. In fact, they're both called bases. So that is what we call a prism. All right. Number 3, find the number of faces, vertices, and edges of each polyhedron. So faces are the flat sides, and you just want to count those in an organized way. Maybe I'll count it like this. I have the front and the back. That's 1, 2. I have the top right and the top left. That makes 3, 4. I have the bottom right and the bottom left. That makes 5, 6. And then I have the square, it looks like base. That makes 7. So I'll just label that 7 faces. Vertices are the points or the corners. Again, when you count these, you want to do it in an organized way. So maybe I'll start at the bottom and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's it, 10 vertices. And edges are the line segments that make up the polyhedron. So I'll start at the bottom with those. I have 1, 2, 3, 4, and then rising vertically, 5, 6, 7, 8, and then 9 and 10 going horizontal, and then 11, 12, 13, 14, and don't forget about this top one, makes 15. So 15 edges. Now that's all you need to do to answer the question, but if I were doing this, I would make sure it checks out with Euler's theorem. Euler's theorem says that the number of faces plus the number of vertices should equal the number of edges plus 2. So let's just plug those numbers in there. 7 faces, 10 vertices, 15 edges, and does that equal out? Let's see, we get 17 and 17. Yeah, so that works out. That should make you pretty confident that you counted correctly. Okay. On to the main part of the quiz, finding surface area and volume. Now for every single one of these, you can look at your formula sheet attached to the quiz, and you'll get the exact same list of theorems and formulas when you take the test. Some of them are more descriptive and have more of a formula than others. And so it'll just depend on what it says. So you have to be able to identify the figure first. Like number 4, this is a cylinder. You have to know that that's a cylinder. Otherwise you won't know which formula to follow. So we actually just have a surface area formula for a cylinder. It's 2 pi r squared plus 2 pi RH. And we've talked about where that comes from, but at this point, with only being a day away from the test or so, you just want to make sure you can identify it and use it properly. So to fill that in, we would say 2 pi, and then r squared is 3.5 squared, since 3.5 you can see is the radius, plus 2 pi r, so 2 pi 3.5, times the height. And 6.8, you can see that is the height of the cylinder, so times 6.8. Now, as the directions say, we're going to try and do this as exactly as we can. We'll also give an approximate answer, but you should try to get an exact answer first. So when I use my calculator, I'm going to enter in 2 times 3.5 squared, but I'm not going to enter the pi in. And when you do that, you get 24.5, and so then the pi will just go after that. And same thing with this next set. I'm going to type in 2 times 3.5 times 6.8. And I'm just not going to type the pi in yet, and I get 47.6. And so these are actually like terms. If you have this many pi's and this many pi's, you can add those together to get just a total number of pi's. So do 24.5 plus 47.6, and you get 72.1. And I have not had to round at all yet. So the surface area, the amount of square meters exposed on the surface, is 72.1 pi. Now, we will also approximate this by typing in 72.1 times pi, and as it says, we'll round to 2 decimal places, so that makes 226.51, and that is also square meters. So give both answers definitely in that instance. Now, don't forget, we're also doing volume, as the directions say. So look at the formula sheet for volume of a cylinder, and it's just printed right on there. Volume of a cylinder is pi r squared h. It's actually a much easier formula. So for us, that's going to be pi times 3.5 squared times 6.8. Again, I'm going to type in just the 3.5 squared times 6.8. I'm not going to type in the pi yet. So the volume equals 83.3 pi cubic meters. And then you can also approximate that and actually times it by pi. And rounding, we get 261.69 cubic meters. So this first example for both surface area and volume is one where you definitely can and should give both the exact and approximate answers. All right. Number 5, we have a rectangular prism here. There's a couple different ways how to think of this. I would think of it as it is a square base, and that square is repeated as you go back in depth. And so when you look at the surface area of a prism, it just says add up the area of each face. And so that's what we'll do. There are 6 faces if you count all of them, but notice that they come in pairs. For instance, this front face is 6 by 6 is 36. This side face over here is 8 by 6, because we know the height is 6 feet there, so it's also going to be there. So 8 times 6 is 48. And the top face is 6 by 8 also, so that's also going to be 48. But remember, each one of those is going to be doubled because the front is identical to the back, and the right is going to be congruent to the left, and the top is congruent to the bottom. So there's a bunch of different ways how you could show this. I'm just going to show how I'm doubling each one, so that 36 becomes 72, that 48 becomes 96, and that 48 also becomes 96, and then I'm adding them. So I kind of showed that in a very informal way. Usually I write out front, back, left, right, top, bottom. But the directions say show some work, and I certainly have, and I think anyone looking at this would figure out what I did for these. Maybe I will go in and just kind of label this front, back, right, left, top, bottom. And so add all of those up, 72 plus 96 plus 96, and we get 264. Now actually make sure to write out surface area, or SA. I want you to label it correctly by putting square feet, but I also want you to tell me, what are you giving me? Is this surface area? Is this volume? Is this something else? Make it clear what question you're answering. So surface area is 264. Okay, now for the volume of a prism is capital B times H. If you look at your formula sheet, it just says capital B times H, where B is the area of the base. So that's not just a single number, it's an area, and H is the height. In this case, I would think of it like this. You have a square that is 36 units, and that square goes back a certain number of units, goes back 8 units, and so that 8 is kind of like the height. It's like if it were only to go back 1 unit like that, this would be, right here, this would be 36 cubic units, and that would be the volume. So it's like one slice of rectangular prism cake here would give you 36 cubic units, but we don't just have one slice, we have 8 slices, and so we're going to do 8 times 36. So I suppose if you really wanted to show it, it would be the area of the base is 6 times 6, and the height is 8, so 36 times 8 is 288. No rounding required on this problem. 288 cubic feet. Alright, on this page we have 5 more problems with the same directions. We're doing surface area and volume for each one. Pyramid is one of the more complicated figures, at least some people tend to think so. And so to find the surface area, we're just going to add up the area of all of the faces. So we have a square base, so we're going to add the area of the square, which actually you can just see right now is 4 times 4, 16. And we're going to add that to the 4 triangles that make up the side faces. So we have a triangle here, and then we also have 2 triangles in the back. Now, the area of a triangle is 1/2 base times height, and we have 4 of them, so I'm going to times it by 4. We know the base is 4, because we can see the base of each triangle is 4, it's given. The height of the triangle, as your helpful formula sheet says, use the slant height, L, for the height when calculating the area of each side face triangle. So we want this height, L, that's perpendicular to the base of 4. That will give the height of the triangle. In this case, that slant height is not given. What is given is the true height of the pyramid, and we're actually not going to use that for surface area. We'll use that for volume. So what I'm going to do is I'm going to draw this right triangle that would go right through the middle of the pyramid. You don't have to redraw it, but I'm going to make it easier to explain. And I want to know this slant height right here. I know the true height is 3, and then actually we do know this measurement also. The height of the pyramid is coming right from the middle of that square, so it goes 2 units in. So this right here is 2. So using the Pythagorean theorem, we have 3 squared plus 2 squared equals L squared. So that's 9 and 4, which makes 13. And then you take the square root, and we just have square root of 13. You can't really simplify that anyway. So now I'll go ahead and write that up here. And so each triangle, if you kind of want to do it one at a time, it would be 1/2 4 times radical 13, which is just 2 radical 13. That's the area of one triangle, but we have 4 of them, so overall that makes 8 radical 13. Bring the 16 down from the square that's on the bottom, and our surface area, our exact surface area is 16 plus 8 radical 13 square centimeters. That's the most you can do without eventually typing that in your calculator and rounding. You might ask, why can't I add 16 and 8 together and say 24 radical 13? Well, because 8 has a radical 13 and 16 doesn't. It's kind of like if you had 16 plus 8x, you would not be allowed to add those because the 8 has an x and the 16 doesn't. Okay, let's go ahead and type that in to round it. So 16 plus 8 radical 13, you get 44.84 approximately. And, the directions say to give both an exact, if you can, and approximate answer. And you can give an exact. I suppose if you only gave me an approximate answer for this one, I probably wouldn't mark it wrong, just because that is kind of an impractical exact answer, 16 plus 8 radical 13. It's hard to really get a sense of how much that is. But ideally, you would give me both. All right, volume of a pyramid. We have a formula for volume of a pyramid. It is 1/3 capital B times H, and capital B is the area of the base. So again, it's not just a single measurement. And H is the true height, not the slant height. So actually the true height that's coming straight up through the pyramid. So this one will actually be a little bit more straightforward. Kind of funny the way that works, that volume tends to be easier. So 1/3 times, and then we actually already calculated the area of the base to be 16. So you can either write 4 times 4, or we know that's going to be 16. And then we know the height is 3. So what's 1/3 times 16 times 3? You can type it in or just figure it out. It actually works out to exactly 16 cubic units. All right, number 7. Number 7, do you see how number 6 and 7 are different? Number 6 is a pyramid. Everyone can see that. Number 7 is not a pyramid. Sometimes people get those mixed up. So what is number 7 then? It is a triangular prism. We have a triangle base, and that triangle is repeated throughout. All right. So to find the surface area, we're just going to add up the area of all of the faces. And we have 5 faces, so you can go in any order you want. I'm going to start with the top face. I can see that it is 40 by 20. So the top, I think it's helpful to label your work, or I suppose you could write it right on there if you wanted. I'm afraid it's going to get messy if I do that, so I'm just going to label it. The top face is 40 by 20, which is 800. Okay. What else can we do here? Oh, the bottom face. The bottom face, you can see that rectangle is 32 by 20. So on the bottom, 32 times 20, that is 640. What else can we do? Well, we have the front triangle and the back triangle, but I actually don't have enough information on those because I know the base is 32, but I don't know the height. So I have to figure that out. And I'm also going to need that height number to do the left side, this rectangle that you can't see. So I know that this slanted part is 40. If you think about that as a right triangle, this is 40, this is 32. We need to know this height number. So just Pythagorean theorem. 8 squared plus 32 squared equals 40 squared. And so let's see here. 32 squared is 1024. 40 squared is 1600. If you subtract those, you get 576. That's convenient because when you take the square root of both sides, that comes out evenly to 24. So that height number is 24. Well, great. Now I can figure out the front, and I'll throw the back in there also because they are congruent. You can see the front triangle is going to be the same as the back triangle. So it's 1/2 base times height. And then since we have 2 of them, because front and back, I'm just going to put times 2. So calculate that, and both of them together equal 768. And so there's one more, and that is this left face. You can see it's 24 tall, and it's 20 deep. We know that because this is 20 deep, so this is 20. So it's just a rectangle, 24 by 20. So I'm calling that the left side. 24 times 20, and that is 480. Okay, so now just add all of those up. So 800 plus 640 plus 768 plus 480, and you get a grand total surface area of 2,688, and that would be square meters. Okay, volume of a prism, as we talked about before, is capital B times H, where the capital B is the area of the base, and H is the height. In this case, the base is the triangle, because that is the shape that's repeated over and over. If I wanted to, I could slice for you a piece of this triangle cake, and I could actually give you 20 slices of it. So it's kind of like this triangle is repeated 20 times, and that's the way the volume formula for a prism works. You figure out the area of the first slice, and you times it by how many repetitions of that. That's what the height means. It doesn't necessarily mean the up and down distance. So in this case, the area of that triangle is 1/2 32 times 24. So 1/2 32 times 24. Maybe I'll just stop and do that. You could do it all at once. But that would be 384. So it's kind of like if you just look at the first slice of that, this slice right in here, that would be 384 cubic units. But because we have 20 of that, we have to multiply that number by 20. So we're going to multiply that 384 by 20. And there we get our volume of 7,680 cubic meters. Okay, number 8 is a sphere. And for a sphere, we need to know the radius. Notice that 7.4 is not the radius. This is pointing at a line segment that goes all the way across. So you have to do 7.4 divided by 2 to get the radius, and that equals 3.7. So the radius is 3.7. All right, now if you look at your formula sheet, the surface area of a sphere is 4 pi r squared. So that's 4 pi 3.7 squared. I'm going to type in the 4 times 3.7 squared, but I'm not going to type in pi yet. And so my exact answer is 54.76 pi. I have not had to round at all, and that would be square yards. That's how many square units would fit on the outside of this sphere. Now, if you do actually multiply that by pi and round, you get 172.03 square yards. Now, I think you should be able to tell that that 7.4 is pointing at a diameter. I know it's not pointing right at the center, but it's pointing at a segment that keeps going. But if you want to ask during class, I'm always glad to clarify that. But that's just something to be on the lookout for. All right, the volume of a sphere is 4/3 pi r to the third. So that's going to be 4/3 pi times 3.7 to the third power. If you're going to type this into the calculator, which you're probably going to do, I would type it in as 4 ABC 3. That's how I do the 4/3. And then I would do times 3.7 to the third power. And if you do that, it doesn't work out quite as evenly as some of our other cases, and that's okay. That's just how this one works out. So this would be 67.537, and then you can see that that 3 repeats. So our exact answer here is 65.537, 3 repeating pi, and that is cubic yards. And if you were to round that and actually times it by pi, you get 212.17 cubic yards. And again, this would probably be another case where just going to the rounded answer would be acceptable. As the directions say, give both an exact and approximate answer, but for exact it says if you can. So this would be a case where maybe in your judgment that exact volume is not really something that's reasonable. Number 9, we have another pyramid. So for surface area, we are going to add up the base, which you can see is 10 by 10, 100, plus the 4 lateral face triangles. Each triangle is 1/2 base times height, and we actually know the base and height of each of those because the base is 10, and this height right here, 16, that actually is the height of that triangle. So 1/2 10 times 16. Now if you just multiply those, you get 80. But the fact is we have 4 of those triangles. So 4 times 80 is 320. And then if we bring down the 100 from above, that gives a total surface area of 420 square feet. Volume of a pyramid is given by the formula 1/3 area of the base times the height. So that capital B is area of the base. We actually already know that because up here we just calculate it. 10 times 10 is 100. So 1/3 times 100. Now this height h right here, that is not 16. Even though 16 is the height of the triangle, if you look at the whole pyramid, 16 is considered the slant height, which we call L. H, the height, is the line that would rise from the center of the pyramid straight up to the top. So we don't know what that is. We're going to have to figure that out. But do you see how that forms a right triangle with the slant height? Here, I can draw it outside the pyramid if it's easier to see. So there's the height that we don't know. There's the slant height, 16. And we actually do know that this bottom figure here is 5 because you can see how that bottom part of the right triangle comes halfway in. And so half of 10 is 5. So we'll just do the Pythagorean theorem to figure that out. 8 squared plus 5 squared equals 16 squared. So that's 25 and 256. If you subtract 25 from 256, you get 231. And then you'll have to take the square root. And let's see here, 231, what can that divide by? It can actually divide by 3, so I'm going to try to simplify it here, and 77. And 77 can divide into 7 and 11. But that's it. We actually can't divide it anymore. So since we don't have any pairs of factors, we are just going to leave that height as radical 231. So that's this number right here. So if you wanted to leave this as an exact answer, all you can really do is multiply the 1/3 times 100. You can either write 100 over 3 and just leave it like that, or I would probably write it as 33 and 1/3, 33.3 repeating. And that's just times radical 231, and that is cubic feet. Now, we should also round that to get an answer that's maybe a little more practical. And it's 506.62. This could be a case where I could see you only giving the approximate answer, just because this is kind of a complicated answer. 33 and 1/3, radical 231. I mean, ideally you'd give them both, just like I did here, but I probably would not take points off if you just gave me the approximate answer, as long as you showed your work and explained everything. All right, number 10, last problem here. This is a cone. If you look at your formula sheet for surface area of a cone, it just gives you a formula, so I would use that. We talked about in class where it came from, but at this point, it's just pi r squared plus pi rl. R is the radius, so hopefully you can see the radius is 27, because that's the radius of the circle. So that's going to be pi 27 squared plus pi 27, and L is the slant height. We actually don't have that in this case. The slant height would be right there, and so that's actually the hypotenuse of the right triangle that's formed by those two numbers. So I'm going to take a break from this and figure out the slant height using the Pythagorean theorem. So 27 squared is 729. 36 squared is 1,296. If you add those together, you get 2,025. And if you take the square root, it actually comes out evenly to 45. So the slant height is 45. That's what's going to go right here. Okay, so back to surface area. If I just do 27 squared, and just leave the pi alone for now, I get 729 pi. Oh yeah, because I already did 27 squared up above. That's where that came from. And below here, if I do 27 times 45, I get 1,215 pi. Those are like terms and can be combined. 729 plus 1215 is 1944, so 1,944 pi square inches. That would be the exact surface area. And if you round that, you get 6,107.26 square inches. All right, volume of a cone is 1/3 pi r squared times the height. Not the slant height, but just the regular height. So that's 1/3 pi 27 squared times 36. 36 is the height, because normally when we look at a cone, the circle part is the base, and that's on the bottom. And so the height is the distance between the base and the tip of that cone, which you can see is 36. So if I just type in the 1/3 27 squared times 36, that equals 8,748. And I have not typed in pi yet, so the pi is there. That is the exact volume. If you do multiply that out, you get 27,482.65 cubic inches. All right, that is our formative quiz. I hope this made sense to you and cleared up a few things. Good luck in your studying.